Have we talked functions before? I think we have a little bit here.
Functions and relations.
Functions and relations. Do you have them? Is it there? Perfect. Because that's what we're talking about. Functions and relations. I'm going to get the brush. Make this a little bigger here. And let's start off with this. First of all, this is a function. If you're given y equals 2x plus 1, and if we were graphing that, okay, when you graph it, remember what we did? We've done a couple different things, but one way we did it was we made a table. Okay, where you got to pick anything you wanted for x and to see what y is. So let's say I pick -1, 0, and +2. Remember doing this. If I put -1 in for x, 2 times a -1 is -2, plus 1 is a -1, right? 0 in for x gives me 1, correct? 0 plus 1. 2 in for x gives me 4 plus 1, which is 5. Okay? This little table we have here, I'm not going to graph it right now. This little table is the same thing that the book a lot of times shows is what they call a mapping. Okay, where these are the x values, these are the y values. We have -1 for x, 0 for x, and 2 for x, and then they draw little arrows that go over here to y, which is -1, 1, and 5. This is what they call a mapping. Okay, and a lot of times, instead of calling them x and y values, okay, they will call the x part the domain. And this is all just kind of terminology that you have to get used to. What it really means, I don't know. And the y values are the range. Okay. And in order to really kind of get what they talk about with functions, here is what you need to write down. Okay. Something is a function if something is a function if, let's say this very slowly, each value in the domain, each value of the domain is paired with only one value in the range. I'll let you write that, and then I'm going to let that sink in for just a minute because it's something that's a little kind of goofy. I'm going to take 3 deep breaths before we go through this. You know how many you take. Huh?
Is that towards the void too, the range of going to?
No. And that's what we're going to talk about. And that's why it gets a little bit confusing here. Okay? So as you look at this mapping here, the only thing you need to look at is, does every x value have only one y value that goes with it? And in this case, yes, it does. Okay? Now, would there be a case when that doesn't happen? Well, that would be this. And I suppose I should do it on a different, let me get a new sheet here. Here's the deal. Let me look at the 2 different cases that you could come up with. Let's say you've got this, and you've got this. 1, 2, 3, 2, and 3. And let's say you've got 1 and 2, 1, 2, 3. One of them is a function, one of them is not a function. Okay, and that's where it gets a little goofy, but you got to think about it just a bit. The rule is that, here's the domain, here's the range. Every domain thing has only one range mapped to it. So if you look at this, okay, 1, 2, and 3, do they each only have one thing that goes with them? Yes. It can be the same thing over here, but it's only one that comes off it. In other words, you're looking for just one arrow coming off of each domain. If it's like this and it has two arrows coming off of it, then this is not a function. But it is, the book just calls it a relation. Okay? If it has more than one arrow coming off of the domain, okay, then it's not a function. It's just a relation. A function is like a certain special kind of relation, I guess. They're both relations, but that one over there is. Now, let's go delve a little deeper here. There is such a thing that we call the vertical line test for functions. Did we do this last year?
I did this.
When?
In our notes, we did like shoe size and we drew the lines.
Oh, we did?
Yeah.
But we didn't talk about domains and ranges, did we?
No, we didn't call them that, but we did
Okay.
the vertical line test.
Good. Let's review that because that ties in with this here. Remember, we talked about this, I guess. That must have been right away. Here's the graph of x squared. Here's the graph of sine, I think. And we have a c that looks like this. You can, if you just look at a graph, you can tell if something's a function if, you remember going back to this, if you draw a bunch of vertical lines that pass only once through the graph. In case we forgot this. Okay, that just meant we did this. You sit here and you go and you draw as many vertical lines as you want. And as long as that blue line only crosses the vertical line, every vertical line only once, this is a function. Same thing here. If I do my vertical lines and I keep going up and down on it, there's no place that this blue line crosses once, so this is a function. However, if you do this, this is not a function but a relation. Why? Because this vertical line crossed both here and here. Not a function. And that makes complete sense because, okay, the rule with that whole mapping function thing, here where x is 2, you know, if you were making a graph of this, of x and y values, here where x is 2, you have 2 answers, which you can't get. I guess if I was doing a mapping, sorry. If I was doing a mapping and I put 2 for x, it not only goes here to maybe where y is 4, but it also goes to where y is -4. So you'd have 2 arrows coming off of 2, 1 to 4, 1 to -4, and you can't have that with a function. An x value cannot go along with 2 y values. Now, in this one over here, you'll notice that, okay, there are 2 x values for a y value, but you can have that. That makes sense. In other words, here at where maybe y is 1, 2, 3, okay, where y is 3, you're going to get a mapping that looks like this. Sorry. Here's y. What's x going to be? Well, x is going to be what? What do I have here? 1, 2, 3, 4. 4 is going to go to 3, and -4 is also going to go to 3. You can have different x values going to the same y value, but you can't have different y values coming from the same x value. That's not confusing at all, is it? And then one last thing here. They will also give you a bunch of points and ask you if the thing is a relation or a function. For example, if you see this, if you see, oh, let's write this down. Write these out for me here. Let's say you're given these points. Wait a second. Let's say you're given these points, 3, 3, 10, 1, 0, 3, 8, 9, 4, 4, and 10, 2. First things first, if I asked you what the range was, what would be the range? What did we say the range was? The range was all of the y numbers. So here's the range. All of these y numbers are the range. And if you're writing it out in set notation, you just go, oh, the range is 1, 3, 1, 2, 3, what else do we have? 4 and 9, right? 1, 2, 3, 4, 9. And the domain is all the x values, which are, what do we have for x? Feel free to jump in anytime there. 0, 3, 4, 8, and 10. Now, if I asked you if this was a function, you may or may not be able to do this without mapping it, but let's map it just for fun. Is it a function, yes or no? Well, let's look. 3 goes to 3. 10 goes to 1. 0 goes to 3. 8 goes to 9. 4 goes to 4. And 10 goes to 2. Function, yes or no? Why not, Jeremy Schwartz?
Because the 10 is going to be different.
You can't have the same x value have 2 arrows going to 2 different numbers. That's not allowed. Now this was fine. I could have the 10 and the 3 both go into 3 because they're only going to 1. But you can't have 2 arrows coming off of 1. So this is not a function. As in a conjunction junction. Is it a function? Is there anything else we need? Anything else I should be made aware of? I thought that was a fun review, don't you think? Anybody else? Look at the perfectly centered camera.